No.
Funny, back out. Why do ears like that? That's a monkey. Does that mean what I mean?
Okay, guys. So we're going to talk about the difference between common denominators and not needing common denominators, like denominators, unlike denominators, and talk about how to simplify these fractions. Notice there is some algebra involved in some of these. There are some variables in there. Again, we're doing this, and we have to do it by hand because we have to be able to do this when we throw, like, if I put a sine or cosine or tangent in there, that you would be able to evaluate and work with and simplify that even if it was something that you couldn't just put into your calculator. So I really ask that on these we're not using our calculators because it's just going to end up kind of crippling you later in terms of understanding. So with adding and subtracting, we need common denominators.
Yeah, we do.
So if they don't have common denominators already, we have to make them be the same. Once they are the same, with adding and subtracting, what's our rule? Like, how would you explain this to someone that's never seen it before?
Just do it.
Just do it. So do the add the numerators, keep the denominators. So we're going to add or subtract the tops depending on what it wants us to do. And then again, we're leaving the denominators the same. So like the 8 and 8 don't get like added together. It just stays as 8. Now we will be simplifying as well, so we want to simplify as much as we're able to. So these first three all have common denominators. If we need to write a little bit more notes on how to get the common denominators, we'll talk about that. But hopefully these go okay. So if you haven't done so already, if you want to try these three, or if you want to look ahead on the next couple, that's fine. Just don't get too far ahead of us, or if you are getting ahead, just make sure you're checking back in to make sure you're doing these correctly. What's that? Yeah, so simplify as well. Yep. Now, simplest form, but you do not need to, if they're improper fractions, that's where the bigger number's on top, you can leave them improper. You don't have to change it to a mixed number. So simplify, but you can leave it as an improper fraction. All right, so I'm going to start going through these. So 5 and 7 and 1 is 13. And then I just leave that over 8. And again, I would leave it that way. Now, technically, that's 1 and 5/8, right? But we actually are okay with leaving it that way. The bigger number on top is perfectly fine.
Okay.
Now, number 2, we go to subtract. I get 4 over 6, but I have to simplify that. So that's going to become 2/3. Now be careful with this next one, and I picked this one intentionally because of the minus sign, but then also because there's two terms here. We're subtracting this whole top here. So it's almost like you have to distribute that negative in. So it really becomes 5 minus 2, and then plus x. So this becomes 3 plus x over x. Now, can we just cancel the x's out?
Nope.
No, you cannot. Pre-calc, what did we call that? Was that killing kittens?
I believe so.
Okay. So
Don't kill a kitten.
We have to show you guys. Kitten killing.
I think
Yes,
it's-
Sam.
Yeah, I think it's kittens. Or it was rabbits.
Oh, it was a bunny. It was a bunny, I think.
Yeah. forgot what the other one was. Which one was the dog?
That's what's on the back side of the worksheet. Or the
Hey,
back.
Joe.
Don't kill a dog. Don't kill a puppy. Guys, go to the girls' game. Luke, it's better to see you there.
Yeah, Luke.
No, you better bring your brother to the girls' game.
No?
And you better be there too.
Jim, I gotta sleep.
And your
I gotta
Leon.
I wouldn't.
You better bring your grandma and your grandpa too. Yeah, and your
Gotta sleep.
grandpa.
have any.
Gotta sleep.
Liar, you literally
Oh,
are
you're doing
hungry.
Matt's thing?
You literally don't have to.
Okay,
Every time you do this, the kid dies.
alright.
Sam. So we do with Kit Kats.
So, alright, so as horrible as this is, if you know me at all, you'll know that I'm an animal lover, so obviously I'm not, I'm not promoting killing kittens. However, this is trying to remind you guys that you can't just cancel because there's a number on the top and the bottom that's the same or a variable on the top and the bottom. So it's trying to prevent you from doing that. Hopefully you don't want to kill kittens. So don't do that. We will, so canceling that X there would kill a kitten. So we don't want to do that. Okay. Our next one here. Am I missing example 6 or is it not? Oh,
It's below.
I don't know. Okay.
That's what I'm saying.
So
These.
now, again, example 4 here, we're adding like terms. And again, same thing here. Don't kill a kitten. Don't just cancel those 5s. We'll talk about when we can cancel like that. It has to do with the fact that this is subtraction rather than being multiplication. Now, this next one, we need a common denominator.
Wait, so the positive, like.
Oh, sorry, it should be positive. It's 4 minus 3. Thank you.
I was so confused.
No, good. Thanks for speaking up. All the rest of you just look terrified and Eric actually said something.
I was a little.
All right.
We didn't do this sheet pre-calculate.
No. Does it look familiar?
No, but like the stuff that we're doing is like very
Some of the same stuff, yeah. All right. So guys, in number 5, we have to get a common denominator. What's our common denominator going to be?
24.
Okay, so there's
69.
options.
No?
No.
Neither of those go into that number.
Right.
Well,
Okay. Now, 12. So first of all, 24 works. However, 12 is a little bit better because it's a smaller number. We prefer to keep the numbers smaller rather than being larger there. So if I multiply this by 3, I have to do the same thing to the top. If I multiply this one by 2, I have to do the same thing to the top. And then we can add our numerators. And then we'll leave the bottom. And then, again, you can't simplify. You can leave it this way. You do not need to change it to a mixed number.
Wait. So
Yeah.
is it right if I did 1 and 1/12?
1 and 1/12 is correct. We just won't need to do that. So I'm not,
No, you're completely wrong. You failed.
because when we're doing that with sine and cosine, we won't have mixed numbers with sine and cosine. Yeah. Yeah, that's not today. Just focus on what's right in front of you. Okay. So some more common denominators here.
We gotta make one 10.
That one 10, yep. So this one will stay the same. Okay. Now I threw some variables in there. So, in number 7, what's our common denominator?
X squared.
Yeah, so x squared is our common denominator. They can both become an x squared. So in order to make this an x squared, I'm going to multiply it by x. Same thing up here.
I did that wrong.
So that becomes a 7x on top. I'm going to add it to 6x. So that'll give me 13x. And then just plus 1. And the bottom is just going to stay the same. It's just going to be that x squared. All right, and then number 8, again, we need common denominators. 12 again. So up here, this one has to get multiplied by 3. Over here, I have to multiply by 2, but since this one has 2 terms, both of those have to be multiplied by 2.
Then it becomes
Okay? But then also, this is being subtracted, so we have to distribute that subtraction in. So it becomes 15 plus 4x, so 19x, minus 6, all over 12, and again, since I can't divide both of those by 12, like by 12 or by 2 or anything like that, by 6, I can't do anything with that, so I just leave it that way. What's that?
I did 24 again.
So if you did 24, then you just have to simplify. So those can all be divided by 2.
because then you get 6 minus 4.
Yeah, so just really quick showing you guys, let's say we got something like this. Now this one can be simplified to be what this equals. It's because I can divide them all by 2. So divide them all by 2 and then you should get this. Now this one, if they're not divisible all by the same thing, we can't simplify any further. So you just have to simplify them.
Okay. Taking this little extra count.
Alright, so let's talk about multiplying and dividing fractions.
I just finished.
So, I think multiplying and dividing fractions is easier because you do not need a common denominator. If anything, a common denominator just causes a lot more work and confusion. So please don't get a common denominator. So multiplying fractions, one of the things I'll warn you of, hopefully no one wants to do this, but you should not be cross-multiplying. Just always have someone suggest cross-multiplying. We can cross-cancel though if you'd like. So you can cancel diagonally if you notice something that you can cancel.
Oh.
Otherwise, we can multiply the tops and then multiply the bottoms. So kind of you can do those interchangeably in any order there, but we're just multiplying our fractions that way. So like in number 9, I would just cancel those 6's and then just multiply across the top and across the bottom to get 1/5. So I like cross canceling, but if it's more confusing to do that, then don't. But and again, we should be comfortable doing this by hand for the most part. Hopefully we make the numbers small enough. Like this one, like 12 times 20 isn't impossible to multiply in our head, but it'd be nicer if we can make those numbers smaller. So I divide these each by 3, and then it's just a lot nicer numbers to work with, or at least a little bit nicer.
I got 63 over 2 points.
So you can still simplify that. You can divide them both by 3. So if you multiply this, you would have gotten 63 over 240. Then you just have to simplify to get the same answer.
Oh, what?
All right. So probably the one that people forget about the most is dividing with fractions. What's our rule for that?
Let's do it.
What's that? Multiply by the reciprocal. So, and some of you guys might have heard it as keep, switch, flip, and something like that, some sort of saying. It's essentially multiplying by the reciprocal. And again, so yeah, this is a time where we don't want to just have to rely on our calculator, because if those were sine functions, you wouldn't be able to just put that into your calculator. So we keep this one, we switch this to multiplication, we flip this one. So 2/3 times 2 over 1. And then this one I can't cancel anything, so I just multiply across the top and bottom. So it just changes to a multiplication problem. Let's flip it over and do the rest of the division, and then we'll take a little break here.
Come on, guys. This is absolute genius.
All right.
Sam, I don't have that shirt.
It's not the exact same style. One of them's like that blue.
Yeah, I know.
Okay, guys.
I was gonna get one of
That's
those.
interesting.
We should all wear them. If I remember, I'll definitely wear it.
I'll snap you.
Okay.
Oh my God.
So guys, number 12 is a complex fraction. Don't let that freak you out. It's just it's division. So it's really 4/5 divided by 7/8.
It's okay. But really, that's
Oh my goodness.
Fifth times 8, 7.
So yeah, we keep this one the same and then change this one to multiplication.
Ma'am.
And flip it. All right. Now this one, actually, I don't think we can simplify anything. All right. Now we threw the variables in. So this is a place where now we can do some canceling. So this does not apply to the kitten rule. Because the kitten rule only has the, we're dealing with plus signs in there. So here we can ignore that and we can do some cross canceling. So I can say the 8 and, or the x and the x squared, I can do some canceling there because there's an x to the first on the top and an x squared on the bottom. So hopefully you guys remember this a little bit from algebra or algebra 2. I know you've seen it in both places. Do you want to cancel anything right now?
4 and 8.
The 4 and 8, so this becomes a 1 and a 2. Yeah, so this is like an x to the first, this is an x squared, there's more x's on the bottom is always the way I explained it in algebra and algebra 2. So this cancels with one of those. So on the top I'm left with 5 times 2, which is 10. On the bottom I'm left with 1x, or just x. And then in 14 we still do we have to flip it and multiply. Alright, what do you want to, oh that should be x to the third. Alright, what do you want to simplify?
20 and
The 20 and the 5. So this is a 1 and a 4.
You can do x or you can do 3x, so then it's 2 on the bottom and 3x in the second.
Okay, yeah, let me. So what Erica said was we can divide the 9 and 6 by 3. So it'd be a 3 over 2. But then she also mentioned the x squared right away. So the x to the third, and this is x to the first, there's going to be an x squared left on the top. So this has 4 times 3 is 12, x to the second because of this and this. Then I'm left with a 2x, no, just a 2x, or just a 2 on the bottom. However,
this is divided by
Oh, I did that one.
yeah, don't automatically think, well, now I multiplied so I can cancel that, or I can be done. Notice the 12 over 2 I can simplify.
What did you divide by? What did you divide the 9x cubed?
What?
9x.
9x to the third and 6x, I divided each of those by 3.
Okay.
And then the x to the third over x to the first, I just said that's going to be x squared on top. Okay?